Hey guys, it's Blogan. In this very important lesson, I'm gonna tell you about variables. This is probably the most basic and fundamental building block from which any program is built, not only in C++, but also in others. I'll explain to you why they're needed, what they are from a technical point of view, and also show you how to create them and how to use them. The lesson will be long, so let's get started. And let's start with the fact that I'll try to explain to you the need for variables. Imagine that you're writing a program that needs to check your login and password. The user enters this data, and then the program checks it with all the logins and passwords that are in the database. Let's imagine that we're writing data input code. Where should this data be entered? The computer must record them somewhere and store them until they're needed. For example, until the moment when this data begins to be compared with other login and password values. In the same way, even before you enter your login and password, all other logins and passwords should already be stored in the database, if they existed before, of course. My point is that any program needs to store information. Information about time, date, quantity, size, and anything else. But how do we store information? We already know from previous lessons that any information can be classified as one of the data types that exist in C++. Some information may be a combination of these types. For example, if you want to store a point in a program in a rectangular coordinate system and the point consists of two numbers, then you can create a data type that contains these two numeric data types inside. We're still a long way from creating our own data types. Let's first learn how to store information of the data types that we know. This is where the variable comes into play. A variable is a named area in memory that has its own type and a value of that type that can be changed. Accordingly, if you want to create a variable, you must give it a name, type, and value. We already know many data types. We know about literals, thanks to which we can set values. We just need to learn how to create those variables. In other words, you should learn the syntax for creating a variable so that you can create any variables in the future. Let me show it to you. When you write code that creates a variable, you must first write its data type. It can be any of those types that you already know from previous lessons. As a reminder, I'll be using int, double, bool, and char types throughout the course to represent integers, decimals, booleans, and characters. Why does a variable need to specify a data type at all? The point is that variables may not have a value initially, but you can still create them. In other words, you ask the computer to allocate memory for your variable. How does a computer know how many bytes in memory you want? The data type is responsible for this number. The compiler sees this type and writes the necessary commands to the computer. If you choose the int type, the compiler will write a command that asks for 4 bytes. But that's not all. The fact is that only ones and zeros are stored in memory. How can a computer understand that these 4 bytes contain an integer or a decimal? Let me remind you that the float type also takes 4 bytes, but integers and fractions are stored in memory differently. This is the second reason to specify the data type when creating a variable. Thus, you indicate not only the number of bytes that need to be allocated in memory, but also indicate how they should be processed or interpreted. After specifying the data type, you press the space bar and write the name of the variable. We'll talk a little further about what this name should be. You can write any number of spaces between the name and the type. You can even press Tab or Enter instead. The compiler will be fine because it skips all the extra characters. It only needs a space between the type and the name. I recommend that you put one space. 100% of programmers do this in most cases. Well, I hope so. After the name, there are several options for the development of events. You can use a semicolon. The semicolon, as before, indicates the end of the command. In this case, you'll create a variable that will contain garbage. I call garbage a value that is located in the memory area that you request for a variable at the time of the variable is created. Any value can be there. And since you don't know it, it can be called an unknown value or just garbage. Why create a variable that contains a value you don't know? In order to set a new value yourself later. After all, a variable is called a variable for a reason. This is an area of memory in which the value can be constantly changed. So what if at the initial moment there is a garbage there? The main thing is that you then set the value manually. There are simple situations when a variable needs to be created, but at the time of creation you don't yet know this value. The second option is to set the value immediately when creating the variable. All you need to do is write the equal sign and the value after the name. Here you can enter literals, other variables, or expressions with them. You'll soon see what I mean. In this case, the variable won't have garbage at the moment of creation. The second option is also called variable initialization, because you give it a value when you created it. Other options are related to unified initialization, so we will look at them in a separate section of this lesson later. You can already jump to the code, but I want to further show you how variables are stored in memory. Let's create 3 variables with different names and values. Here I wrote a code that creates 3 variables. The first is of type int, the second is double, the third is char. The first is called age, the second is weight, the third is character. The first has a value of 10, the second 74.5, the third has no value respectively. It stores garbage at the time of its creation. Below, I've drawn a long line. This is your computer's memory. Moreover, RAM or RAM, because variables are stored in it. In it, you see squares. Each square is 1 byte. I highlighted the area of the first variable in blue, the second variable in green, and the third in red. Each variable has a different number of bytes, so you can see that they occupy different numbers of squares. All these areas have their own names. Why do variables need names? So that you can access them in code. In the distant past, variables didn't have names. Any programmers manually wrote the memory addresses where they wanted to write values. It was a pain, and it's good that now you can come up with a short, beautiful name for a variable that always referred to it thanks to this name. Also inside these areas, I wrote down the values of these variables. The question mark on the third indicates that we don't know its value because it's garbage. I'll tell you in more detail about the types of RAM and how variables are placed in them in one of the future lessons. Now we can safely move on to the code and try to create variables ourselves. Let's agree for now that we'll create variables inside the main function. You can create variables outside it and even in other functions, but you don't know yet how it will all work, so we'll limit ourselves to the main function. Here you can see that I've created a lot of variables. They have different data types. I tried to show you all the possible types of data that we previously analyzed theoretically. First, I chose the first option of creating a variable, that is without initialization or initial value. They all contain garbage, means the value of which we don't know. I separated the variable groups with an empty line to emphasize the following. These are integer data types. These are also integer data types. You just explicitly specify that they must be signed, but with these types you don't need to do this, since they are signed by default. You should also know that the types short and long are shorthand for short int and long int, so you can explicitly specify the word int in the third group, but again, this is not necessary. These are unsigned integer data types, these are decimal data types, and these are character data types. If you're using Visual Studio version 2022, more or less new, you can see the 2 dots under the name of all these variables. They appear when the program has analyzed your code and has some suggestions for possible improvement. If you look at what this advice is, in this way, we'll see that it tells us local variable is not initialized. That is, you didn't specify a value for it when creating the variable. Visual Studio simply recommends not creating variables without an initial value. Even if you don't know what value to give this variable right away, you can give it the simplest value, 0. The program recommends setting all variables to the 0, though recommends giving the bool type the value false, which is also interpreted as 0. We'll then initialize these variables. I ignore this recommendation because I know my code better than Visual Studio in this case. If you wrote everything correctly, then your compiler shouldn't underline anything. What mistakes can you make when creating variables? You may write the data type incorrectly, for example like this. You can also create two variables with the same name. Although the compiler won't highlight this, it will give you an error when you run the program. You must understand why this is a mistake. If you use this name, the compiler won't understand which variable you want to refer to. Also, you may not add a semicolon at the end of the variable creation line. Creating a variable is a command and must end with a semicolon. Let's now use the second option for creating variables, that is, initialization. At the same time, let's remember all the possible literals that we studied in the previous lesson. Here you see all the same variables, but now they are all initialized with the values that I came up with. In doing so, I try to choose literals that have the same type as the variables. You already know that the short type doesn't have its own literal, so I initialize the variable there with the literal of type int. Also know that I use the apostrophe to delimit the digits in the literal to make it easier to read. This is not necessary, but it does make the number easier to understand. Okay, now let's come up with some really useful variables of each type. Because if we look at the variables that we've created, we don't understand their purpose. What were they created for? So let's create new variables, give them meaningful names and meaningful values. Here's my option. Here I've divided the variables into 3 groups. Try to analyze their names. Thanks to clear names, you can understand the purpose of each variable more or less. It's very important not only to create variables, but also to give them clear names and not only to them. This increases the readability of the code and reduces the time spent understanding it. Therefore, every time you want to create your own variable, clearly define its purpose and come up with a name for it that will reflect its essence. You must not only be able to write code, but also be able to write beautiful and understandable code. Okay, let's get back to the syntax for creating our variables. Imagine a situation where you need to create several variables of the same type. You can do it this way, that is, simply create one variable on each line, or you can create them on one line, separated by commas. In this code, all variables that you write separated by commas will have the type that you specified at the very beginning. You can also initialize each variable separately. I wrote an example in which there are 4 lines. In the first, both variables are garbage. In the second and third, only one of them is initialized. In the fourth, they are both initialized. There is a small point here that I'd like to discuss. Firstly, you can write any number of variables separated by commas. Secondly, remember that in this case they will all have the same type. Thirdly, I believe that you shouldn't always create variables separated by commas, even if they are of the same type. Why? Because they may have different goals. Look at the code for creating the sides of the rectangle. Both variables are the length of the sides of the rectangle. Their purpose is very similar. We can say that they belong to the same entity, a rectangle. But if you're creating variables that have nothing to do with each other, it's best to create them on separate lines because it can highlight that they have a very different purpose. Okay, we already created a large number of variables, but haven't used them yet. Let's correct this defect. You must understand that you can write a new value to a variable at any time and read that value at any time. What I mean? Read means getting the value that is stored in the variable and doing with it what you want. For example, it can be displayed on the screen. How can we display the value of a variable on the screen? To do this, you need to use the cout tool and specify the name of the variable, like this. If I run the program, I'll see that the value of the variable is displayed on the screen. Please note that the variable name isn't displayed on the screen. It would be displayed if you displayed text rather than a variable. That is, you put the variable name in double quotes, like this. You can display variables as you wish and with any other data. Look at this code. Here I've created many variables and output their values in different ways. That being said, I advise you to completely rewrite this code and try to understand why the console output is the way it is. Note that you can not only display just variables to the screen, but also display them along with other data, such as text literals. The most important thing is that each data must be separated from the others by double triangular brackets. You can create variables in any line of code. The main thing you must understand is that before you can use a variable, you must create it. If you try to access a variable that doesn't exist, the compiler will give you an error. Likewise, if you create a variable after accessing it, the compiler will also throw an error because it compiles the code from top to bottom. You should also know that you shouldn't read the value of a variable that contains garbage. The Visual Studio compiler throws you an error if you try to do this, but other compilers aren't required to do this. For example, with other compilers, your program may run and you will see a random number in the place where you display the variable on the screen, so be careful. We've learned how to create variables. We've learned how to read their values. All that remains is to learn how to write new values to variables. Since variables are called variables, this means their values can be changed. How and when? First, I'll answer the question when. When you've created a variable, after its creation, you can set its new value at any time. And you can set new values any number of times in any line of code. The main thing is not to forget that we're still in the main function and don't go beyond its limits. How do you assign a new value to a variable? To do this, you must write the following command: variable name assign new value semicolon. This is a fairly simple and straightforward command. Your variable will be written to the specified value when this command runs. Look at this code. Here I continue to create different variables. Some of them don't have an initial value, that is, they're not initialized. Some already have initial value. With this example, I want to show you how and where you can assign new values to your variables. There are some interesting things here. Note that you can assign not only literals to variables, but also other variables. It's important to understand that here you're copying the value of the first variable, not moving it. Both variables will have their own values, and if we change the value of one of them, the second variable will remain with its value. Now let's get back to the syntax for creating a variable. Here we've so far examined only the first two methods. I highlighted them in green because these are the most common ways to create a variable. I personally use them, and in most cases I've seen others use them too. Pay attention to method number 6. It works exactly the same as the second one, but instead of writing an assignment sign, you put the value in regular brackets. Despite the fact that you can also initialize variables this way, this method is less readable than the second, and accordingly you're unlikely to be able to find code where other programmers use it. Therefore, I advise you to avoid it too. But methods number 3, 4, and 5 are special. These are called unified initialization. Its essence lies in the fact that the compiler checks whether the value can fit into the variable. Look at this code. Here I created several variables of the same type and initialized each of them with one value. The value 10 fits entirely into the int type, so all three initialization options work the same. But the fact is that you can assign a decimal, a character, or even values of type bool to an integer variable. It works and you need to understand how. First, take a look at these lines of code. If you assign a decimal to an integer variable, the real part is simply discarded and only the integer part will be stored in the variable. Nevertheless, it turns out that a decimal doesn't fit into an integer type and part of the information about this number is lost during assignment. The situation is better with characters. Since each character is in memory is stored as an integer value, the integer variable is simply assigned the index of that character. Well, the same situation applies to logical values. The literal true is the number 1 and false is 0. So unified initialization gives you the opportunity to check at the compilation stage whether the value fits into the type of the variable. For example, if I write like this, then here I'll get an error at the compilation stage because the compiler will understand that I'm assigning a decimal to an integer variable. Note that both options work the same, so you can choose the one you like best. However, I always initialize variables in this way because I guess I'm careful about what I assign to variables. Although I think it would be correct to use unified initialization all the time, because we can be careful all the time. But there are also situations when you need to assign decimals to integer variables, for example, to store the integer part of a decimal. We'll start learning about different operators soon, but before that, it might be helpful to tell you that when you work with variables, you can use different mathematical operations on them, such as adding, subtracting, multiplying, and dividing. You can build different expressions in which your variables will participate. Here, I've written a lot of code in which I ask you to pay attention to what I can do with variables. You can add different numbers of variables between each other and write the result of this value into another variable. You can also subtract the values of variables from each other and immediately display the result on the screen. Likewise, you can use mathematical operations on literals, not just variables. You can also use mathematical operations between variables and literals. The main thing is that you understand that in fact you are only operating with the values of the variable and the literal. You can construct complex expressions using parentheses, so expressions that work in mathematics will also work in C++. We will talk in more detail about these and other operators in a separate lesson. In principle, we're done with practice, but I'd like to raise a few more topics so that you better understand the code and be able to write beautiful code. In the C++ language, there is such a thing as a keyword. These are special words that are reserved for the C++ language. You can give your entities names that are similar to keywords. Visual Studio highlights keywords in blue by default. For example, these are the words int, double, return, char, and many others. Throughout the course, when we study the language itself, we'll come across new and new keywords. Look at this table. Here is a list of all the keywords in the C++ at the moment. We'll cover most of them in our course. Why am I talking about this right now? The fact is that in this lesson, you learned how to create your first data, variables. And the C++ language allows you to create other data, constants, arrays, pointers, references, classes, structures, enumerations, and so on. All of them can be called entities, and they all must have a name when you create them. There are several naming rules for all names. For example, the first rule is not to name an entity with a keyword. Try to create a variable called int, and you'll see an error at compile time. Let's talk in detail about these rules. Since we can only create variables now, you can only apply this list of rules to variables. But in the future, I'll say that these same rules work for other entities. What could possibly be in a variable name? It's uppercase Latin letters from A to Z, lowercase Latin letters from A to Z, underscore character, and any Unicode character. In most cases, variables are named using the letters of the English language rather than another language. Names can also have numbers, but the name mustn't start with a number. Why? Because a variable name can have one character, and if this character is a number, then how can the compiler distinguish the variable name from a regular number? There's no way. So that's why it's prohibited. Once again, you can't name a variable with a keyword, you can't start the variable name with a number, and you can't use all other symbols except letters and underscore. Okay, we've got the rules out of the way, and now I'd like to give some tips on naming your variables. In programming, there's such a thing as code naming style. These styles describe exactly how you should name your entities. The most popular are uppercase, Pascal case, camel case, and snake case. Here's a table of these styles. I'll explain them now. Pascal case says, each entity word begins with an uppercase, followed by lower cases. Camel case says the first word of an entity begins with a lowercase, each next word begins with an uppercase. Uppercase says each letter of each word is an uppercase, underscore is written between words. Snake case says every letter of every word is a lowercase, underscore is written between words. Why do you need these styles? To discipline your own coding and to again write clearer code. How can these styles help your code become more understandable? Imagine the situation that you are already working in a company with other programmers. You're given a document that says all variables are written in camel case style. And now, when you look at the code, you understand that this entity is a variable, but this one isn't. Personally, I always name variables in camel case style, so throughout the course I'll name them in this style. You can choose your own style, the main thing is to stick to it. Soon we'll study constants, so I write them in the uppercase style. Lastly, always try to give your variables meaningful names. They should be as short as possible and at the same time as clear as possible. Often code with variables that have short names looks more concise, but understanding of this code suffers, and code with variables that have huge names look cumbersome. Sometimes finding balance is quite difficult. Therefore, I advise you to analyze other people's code and your own. Is it clear enough from the name of the variable what it does? If not, what would you name this variable? Does the name of the variable reflect its essence and purpose? If not, what should it be called to make it clearer? Ask yourself these questions often when writing and reviewing code, and other programmers will like you more. Well, let's summarize. A variable is an area in RAM that has its own name and stores a value of a certain data type. You can create any number of variables, give them different names, change their values, and use them in other expressions. Remember to give your variables meaningful names and try to stick to your coding style. In the next lesson, we will learn how to create new entities, constants. They are very similar to variables, so it will be easy for you if you understand this lesson. And that's the end of this lesson. Thank you for watching. If you like this video, you can support me by liking this video, writing a comment under it, subscribing to the channel, donating using the link in the video description, or becoming a sponsor of my channel. All these things popularize my channel and motivate me to continue recording lessons for you. Goodbye.